on the world becomes geographic information and systems. So geographic means it's pretty much everything that you see outside in the world. Okay? That means it can be any surveying data that you are capturing. All can be geographic. Starting from, let's say, electric poles to the railway lines, to the highways, to land use, land cover maps. Everything can be actually geographic. Information is that, what is that? The information about this, that is what we call the information. And it can be in terms of the database it is being managed, right? Whether it's a relational database, whether it is a spreadsheet, or whether it is a scan image, and so on. Okay? And then you have the system, that means you have a computer, hardware. Okay? And they are all being developed actually for value. As you can see, watershed modeling, then you have for customer modeling, arc maintenance, forest fire modeling, oil spill trajectory modeling. Then you have nowadays project for what insurance cases as well, drought early warning systems. Then you have forest fire early warning systems, and goes on and goes on. Okay. So ultimately, the information that we derive using the GIS is to improve the decision-making process. That means it is a very good ultimate. I mean, when you use these systems, it can be used as a decision support system. Okay, DSS. All right. So GIS is something that now you can find it mostly in civil engineering department. But also you can find in the science faculty as well, right? In forestry department sometimes, in ecology you can find, and then you can find also in archaeology, right? Then there, the guys who use the architect, okay? So the applications are many, okay? Then it's like salt, you know, wherever you can use it, actually it can be mixed. Now, what is GIS? If you want to define GIS, so in classic way, this is a system of capturing, storing, checking, integrating, manipulating, analyzing, and displaying the data. Again, coming back to this, partially reference to the authority. That means it has a coordinate system. It is not just actually any kind of data that we are talking about. Okay? Then, obviously, it has got a hardware, software, and the procedures. Procedures means the protocols. Right? That means the guidelines. Otherwise, it's just a garbage in and garbage out. It's just a system. Whatever you give the system, input to the system, obviously you can get the result. But the logically getting the result and the right output, that is what it is supposed to be. Okay? Then, if you look at the component of the GIS, so as I was mentioning, you have software, you have the data, that is the database management system. Then you have the procedures, that means the guidelines. Okay. Then there are hardware, there is the computer hardware. There is the people like us. Okay. The data scientist or spatial scientist. Okay. And these are I already spoken about yesterday. See this. And GIS only handles the spatial data. Okay. Now, this technology, if you look back to the history, this technology has developed from the CAT. Okay? And slowly it has taken the shape of the modern GIS tools and software that we are seeing today. Okay? And it follows a similar kind of DBS, the database management system, that what the computer scientists also use it as well. So that means it's one-to-one relationship, one-to-many relationship, many-to-many relationship exists in the data. And that relationship what makes actually the data enriching. Okay? So how you collect the data and the spatial relationship between the data is also very, we'll learn about it. I have put it in a very, very simple way. So those who have never been introduced to GIS, we can get to understand. Okay? So ultimately, it has to be X and Y. That means the maps, typewriter, manual drafting tools, all of them can be called as actually the forefather of GIS. Okay, but the new generation GIS are all about computers, right? Computer, launcher, and obviously CD-ROM you need no more. Right? CD-ROM, PDs, so many things like that, but right now they all have become obsolete. Okay. Why the need of GIS? We have understood. Obviously, we want to manage natural resources, we want to manage so much of data, whereby the human being not being able to actually crunch the data, understand the data. That is why actually we need a system. That is why the GIS becomes very useful. Okay, so it becomes for manipulation and analysis and modeling and forecasting of different scenarios for a given application. Okay, so some examples I have given, like the neighborhood of the intended purchase of the house. Let's say if you are moving now, let's say someone is moving to Sydney, okay, and it's a big city. Now you would like to do a map, and you have a key. Now you are looking at where is the good place that I can live or rent a place. Now there are so many things that has to go into your decision making process. That means the proximity to your working place, how long it is going to take, the proximity to the public transport services, because you don't have a car, okay, the cost, okay, cost of the rent, okay, so these are actually variables, okay, cost of the rent, proximity to the school, and this quality of the school, rank of the school, okay, in the state, so many, and the list goes on. And if your husband is fussy, he would have his own, okay, husband or wife, whoever. So when you have so many variables actually to take into consideration, that is, I'm just giving a very simple example. That is where actually when when it becomes actually complex, that's why we need this kind of systems. Okay. The route for firefighting vehicles to fire detection. That means if there is a fire is happening, what would be the best way actually to get into the area to put out the fire, for example. Location of historical sites to visit, and these things are already being people are using. A lot of agencies also have been using the GIS. Okay. Similarly, the Earth's surface also has a very limited resource. So to efficiently manage our resources, obviously we need the GIS. Okay. So we don't know why some of these precious minerals are very expensive. Why? Demand and supply. When the supply is less, and the demand is high, obviously the price goes up. Isn't it? Gold is expensive. Now, what? Why did 5,000 1 gram? Right? Why? Because we don't have much gold left. But let's say imagine there are 5 or 6 countries now they will find huge reserve of gold. You see, similarly goes also for oil. Because India doesn't have much oil, right? Oil reserve. Now if you find actually a lot of reserves in Lakshadweep or somewhere or the up coast, and these are the non-renewable natural resources, right? So once finished, it is gone. Now they say, NASA is saying, there is a huge reserve of gold probably is in Mars. What does it cost? The cost of going down, digging down, or just to get some ounce of gold. That is what is expensive. The same also goes for diamond. Right? Even more rare. Okay? Platinum, more rare. Right? So that is why the limit, because of the limited resource, so we can probably use, and they are using GIS for managing the shaft and the different ways that how they can planning of the digging down the dirt, all that. Also they use 3D GIS. Okay. And also this helps for fast and quick information for decision. Because ultimately we have to make the decision quick. Okay? Good. This I can skip. Now, there is an old saying it goes, a map or a figure speaks thousands of words. Right? Our mind actually captures very quickly when we see some graphical images, rather than actually having presenting thousands of words. right? It gets quota. Might get confused. But if it is a image, if it is a map, if it is a graph, immediately we can be able to understand and we can infer actually the information. I have given a simple example. The example is from the Peninsula of Malaysia. So now you see, if I give, and they have only got 47 states of it. Yeah. But now in India, let's see if I give you, but how many states are? So sorry because it's keep on increasing, so it's very hard to follow. Alright? So 28 states, let's say. Now, this is just one information that is given here, population. Now think about complex of information that you can put. Keep on GDP, literacy rate, blah 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 blah. Just keep on adding, right? Then whether the information that you would like to visualize and can be able to derive information, is it from here or here? So the graphical representation becomes much more easy, and that's what makes actually the GIS very powerful. But it's not being limited there. Many people they think that GIS is all about map. No, not at all. It's beyond map. Map is just one of the output just to present it. But you can do reporting as well. You can use GIS for creating a report. With GIS you can do report, then visualization, then simulations, then predictions, everything can be done there as well. Then location. So now I'm just going into a little bit of technicality of the GIS. Okay. Now imagine you have three different types of features here, and we have given some local coordinates because at the end of the day it's all about coordinates, right? So here I have given here east and south. Now if I would like to say where is the X located, how do you define it? It is 3 of south, 3 of south and 12 of east, right? So another question I put, what can be found at a certain location? For example, what can be found at 5P south, 5 of south, 5 of south, and 11 of east. Okay? So this is just a simple example for you so that you can understand. But now, when you store the data, so obviously this is just a map representation, but the data has to be captured in a database, right? So that means each feature should have a unique feature ID. Then you should have its X and Y. Unique feature ID I mentioned. Okay? Yesterday I mentioned you all data should be captured in points because the line also represents connecting between 2 points. The polygon represents actually connecting multi-points and closing it, right? So ultimately this is all about the point, right? And each point should have a unique feature ID. Okay? And then you have its X and Y values. Now let's look at the other part of the GIS data. One is the spatial, another part is called attributes. Attribute means what? The information that actually that particular point contains. Okay? For example, here I will give you a very simple example here. See, there are about 5 data points I have, or 5 locations you can say, or 5 feature points you can have. And then each of them, let's say, it provides the area. What is the area of these points? Who the owners are? What is the tax code they have? And what is the mineral quality they have? It's just an arbitrary example that I have given. Okay. Now, if I ask a question, what is the attribute for item 2? Item 2, the owner is Raudo, and he has an area of about 50,100 hectare. Tax code is falling within the bracket A, and mineral quality is blah blah million. And let's say there is another question I ask, where a certain scenario might happen. See, these are the questions that you can ask when you have the data. First question, what is the attribute? Where? What? Okay. Second is what scenario? Example, who has the highest quality of mineral? Ultimately, it's all being managed by Excel, right? Because Excel data also can be, as long as you have the XY. They all GIS allows you actually to convert the data from one to another. So it's database form. Okay. Then, now let's look at the relational database. Okay? So, same example, the owners are there and the tax code mineral quality. Now the question I asked, selection of an area, okay, according to the rules that we have set. For example, which item has area greater than 40,000 people? That means all of them? All of them has 40,000. Owner is not cinema, that means you exclude this. Okay? Tax code is paying B, that means only 2. Okay? What is the mineral quality? Tell me. Yeah. So what is the mineral quality? High? Why? Area is greater than 40,000 or owner not cinema excluded. Tax code is B, so that means 1 and 3. So the mineral quality can be high or low. Why are you expecting only one answer? Yeah? I mean, this is an example, simple example can help you. That means just to understand that a lot of queries can be done when you have the database. Right? I mentioned, right? GIS allows you to query. Okay? Now, let's look at the trend and relationship. Okay? Here, we have 3 different types of features. X, Y, and Z. Okay? Now, if I ask the question, is object X in the pattern? Yes, it is going in a trend like that. So, this is how the GIS works. That means the relationship between the data is a very, very critical. Okay. Is there a relationship between X and Y? Yes, because they are always together. The spatially they are always together. What other spatial variability you can see? Z always close to the boundary, right? Also you can see what? What is? And Z also the size of the Z has increased, right? Z has increased once you goes from left to right. Okay? So let's look at some another applications like trend questions. Okay? So we have 3 features A, B, C. Now these 3 features, that's how it looked like in 1980. Now this is what it looks like 1990. Okay? There's another feature also has been introduced in D. Okay? It's good actually if you want to understand the language curve analysis. Okay? Population changes and all those kind of change analysis that you can do. Okay? This is where you can also see the trend. So what are the changes for A, B and C from 1980 to 1990? You can see everything has changed size, right? A has become bigger, C has become smaller, B also has become smaller. Okay? What have changed since 1980 overall? You can see A and B have changes in size, obviously I mentioned. Location of B has changed. Okay. C changes also the shape. It has all elements like become like pattern and addition of pattern. Right? Then how do you do the land use change curve analysis? Land use land curve change analysis. There might be maybe 30 years ago there were about 25 land use classes. Now maybe 5 or 6 land use classes have vanished. It's all about settlement. Or construction. Okay. But now, if I have to say that, okay, the government says that no, I would like to have a very sustainable growth. So that we must reserve this much of land actually for forest resources, as agricultural land, must keep them. So that means you have to keep them as fixed. Then whatever resources or other lands that you have, you would like to project that how they can be utilized. Then you can do site suitability assessment and blah 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 blah. Okay? Now let's quickly look at data structure. Okay, so GIS has got basically 4 types of data structure. Now let's look at spatial data types. There can be continuous data, this can be aerial data, this can be network type of data, there can be point data. Continuous data means, some examples I've given you. Rainfall is a continuous data, elevation is a continuous data. Then salinity, ocean salinity, chlorophyll, okay, ocean color, that is also continuous data. And also elevation I already mentioned, slope is a continuous data as well. Aspect, how can it be? What is aspect? Okay, while asking you, I can have my coffee now. What is aspect?
Orientation with respect to slope and direction of slope.
Direction of slope. Orientation of the slope or direction of the slope. So how many types of aspect we have? 9. Flat. Okay. But there is no direction. Yes. Okay. So let's say 8. So that means, how can it be continuous? When it is bounded by 8 and each of them has a very specific direction, it can't be continuous. So it's a categorical data, right? Then curvature. What is curvature?
Concave or convex.
Huh?
Concave or convex rate of
What is the
inverse of it.
what is curvature? Basic, first we go to basic. What is curvature?
Changing rate of slope.
Hmm? Change the rate of slope, yeah, you can say that. Yeah, change the rate of slope, or you can say also the what is it? Just now you hijacked my it's called, but anyway, rate of change of slope also you can mention. Okay, so there are 3 types of curvature: concave, which is actually like this; convex, which is like undulating like that, or it can be flat. Okay, and these are very important geomorphological parameters that is being used for various geohazard applications. Curvature. Okay. So now let's look at areas. Areas can be also unbounded type of data, bounded type of data, moving type of data also. Unbounded means land use, market areas, soils, rock types, but they are also can be considered as bounded depending on how you represent. Even slope you said, but I can also categorize it. Okay, let's say I come up with a guideline that I would only allow, let's say I am the government of India now. Okay, now I would say only I would allow you the field areas, okay, slope which is less than 25 degrees can be used for the construction activity. Okay, so then depending on the requirement I can actually categorize the data. Right? It's not a hard and fast rule, but you must understand what is the continuous data, what are the categorical data, and so on. So, and then you have bounded like city, country boundary, obviously that you cannot change. Can you change? Pakistan will come and attack you. Okay? State boundaries also they will fight with you. Right or not?
Yes.
Normally state boundaries follows actually river. Right? Then ownership parcels also you cannot change. It is 100% bounded because you go and और किसी का जगह पे कब्जा करो. So it's 100% bounded, right? Zoning as well, parcel zoning, everything is all bounded data. There is another type is called moving data. Air masses, pollution moving, or maybe animal herd, they don't stay in one place. Okay, GIS is also being used for tracking actually the animals in the forest, like let's say elephants, deers, and so on. Okay, shark. 15-18 years ago, I had done a project for developed a system for
catching the bluefin tuna using the remote sensing. Bluefin tuna fish is one of the most expensive tuna fish. It can run into thousands of dollars per kilo. Okay, so in the vast ocean, that if there is a fisherman going, a ship is going, so how can I tell them with the technology that I have where probably they can go and catch the fish? The likelihood of getting the fish will be high. Huh? So that's the real time. Ocean is real time. I mean, it's a very dynamic environment, isn't it? Every 15-20 minutes, the sea current changes, direction changes, everything changes. Still you can do it. Okay. So nowadays, the hi-fi actually the vessels that they use it for deep sea fishing, they already have embedded in that. They just don't go simply, and at least with 60 to 70% of probability, they know where likely they can go. अंधेरे में वैसे लाठी नहीं मारते हैं. Okay, because it costs. One time they go to the sea, it costs a lot of money. Okay, then there is another type also, network data, like road, transmission line, streams, and blah blah blah. Point data, which is fixed point. Fixed points are wells, street lamps, addresses. Moving is cars, fish, deer, and animal herds, and so on. So now you understand pretty much all kind of data you can categorize in what type of category they fall into. Okay. Now, when you say the GIS data, basically, as I mentioned, it is categorized into two types. One is spatial, another one attribute. So spatial is the location. Where? The location. Attribute is what? The information about that, where. That means what, how much, when. Okay? So now I have broken down into very basic things so that you can be able to understand. Okay, are you getting me? Okay, how much quantity? What is the population? What is the temperature? What is the humidity? When did this incident happen? Those kind of information you can tag in your attribute table. Okay? And this can be both quantitative and also can be qualitative. Qualitative means the name, the owner, like just now I gave you example, right? Quantitative means digits, numbers. Okay? Now, this I have already mentioned it. Okay, now let's look at the characteristics of the attribute data. Okay? Again, it is being classified into two types. One is categorical, another one is numerical. Categorical is basically text, string, right? So that, for example, the name is one of the good example. Okay? Again, it can be classified into two types. One is nominal, another one is ordinal. Nominal means there is no inherent ordering of the data. There is no ordering of the data. That is, for example, land cover types, soil types, administrative boundaries and all that. Okay? That is nominal. Ordinal means there is a ordering of the data. For example, road class. Okay? Class 1, class 2, class 3 and so on. Or primary road, secondary road. Okay? Like that. Okay? And then you have stream class also. Right? Order 1, order 2, order 3. You know, right? When you want to do the catchment analysis and all that, that is required as well. So that's why you have to understand what is the difference between these different types of data. Attribute data. Numerical, it's all about values. Again, it is of two types. One is interval, another one is ratio. Only difference between interval and ratio is that in the interval there is no true 0 point. Whereas in the ratio you have 0 point. That's why actually you can be able to calculate the ratio. Okay. So for let me just give you an example of the interval. That means temperature readings. There is a fixed intervals. Let's say if you are taking it 20 degree, 25 degree, 30 degree, so every 5 degree difference. Alright, elevation above sea level 10, maybe 200 meters, then 10. So it follows actually a pattern. time of the day. Similarly for the ratio, it's some examples like population counts, then lengths or distance measurement and so on. Okay? Only remember the difference is that the ratio has got a true geo. Okay? Are you getting me?
Yes.
Now, so let's look a little bit deeper into the spatial data models, which is the vector and raster. This is already mentioned to you. Vector is point, line and polygons. Now, what are the primary versus secondary data source? It's not always that when you are engaged in a project or trying to solve a problem using this technology, it's not necessarily you are lucky enough actually to get the primary data source. That means whatever you want, the data is there. Someone has to just give you the data, not take it. That's not going to happen. Most cases, that's not going to happen. So you've got to have an indirect approach of getting into secondary data source. Right? That's good enough if you have actually some good quality secondary data source as well. So surveying data is 100%. If that data you have already, that's the best data that you can have. Correct? Or GPS, obviously, and remote sensing data. Or there are other type of also data you can use, digitization, photogrammetry. If you do not have, let's say, some information that you need for surveying, you can also do digitizing. Like when I learned remote sensing in IIT Bombay those days, we used to do that. At that time we didn't have this LiDAR. There was no exist of LiDAR at that time. So we had to do the geodesy, the traditional geodesy way of the parallax and then creating actually the three-dimensional points. That means you take two images, drag on each other, and then you just trace it. Okay? You don't have to do it now. Everything is so automatized now. Okay? Then photogrammetry, that is what actually is the technology that I was mentioning, to extract measurements from photographs and various image sources. Alright? You would be surprised. Remote sensing data was available with Russia and with the US since 1920s. Once the Cold War was finished, and no one knew how much of data they had, but they have secretly developed this whole system, and the data they have about each other and all that thing. So once the Cold War ended, slowly they released those data, which was primarily used for military purpose. Okay? But obviously we didn't have at that time. ISRO launched its first satellite in 19. And that also they carried in the Belgrade cycle and all that. Okay? Alright. Now let's look at the difference between raster and grid. I'm not going to give a break because I know it's match. So we finish and then we all go. Okay? 2 hours is okay. You want to have pani in Godo? But now उसमें 15-20 minutes जाएगा for sure. Okay, so let's finish it up. And the rhythm will be lost. So let's look at the difference between raster and vector. This is what I was referring to. Right? The raster is basically the pixel, right? So, and the vector is the lines, for example, here. So, in raster you have continuous surface, isn't it? The pixel value, you see. In vector you have, when you have polygons, basically that is discrete. Right? Elevation data, that is continuous. Okay? But in vector, if you take for example a land land cover, yeah, but you convert it into raster, it shows like actually there is a continuous. Isn't it? So you've got to understand actually the data structure. Right? So when you do the conversion from data one to another, if you don't understand how much of error it is being capturing, otherwise it would be just become a garbage in and garbage out. Okay, rubbish in, rubbish out. Alright? Now, this is a very good example that we can understand. Those who do not understand about this concept of spatial data models. Point, line, polygon. Okay? This is point. X and Y axis, so obviously the coordinate is there. The same thing when it is represented in the raster data model, it just becomes like one. Yeah, bring. In Australia, you can do anything in it. You can do in the classroom. Even the undergrads students. It's very annoying, but they're free to do anything. You can't stop them. You'll be just hanging around. Sometimes you'll go there. So annoying. You can't tell anything. It's the freedom. But in my class, obviously no, but yes. So we don't have to, basically all the lectures are pre-recorded. So for them it's not mandatory to come to the class. Okay, there is no exam. There's nothing there to memorize. Okay, so everything is canvas based. That means problem will be given, you solve the problem. Okay? Nothing you have to memorize, huh?
No exam?
No exam. But it's not easy. No exam, because we used to have one final exam, but then ultimately students started telling that it's creating so much of stress, affecting our mental well-being and all these things. So yeah, so the exams now being abolished. Everything canvas based. So all the lectures are already pre-recorded. Okay? So we don't have to give a lecture as it is like what we're doing. So we can have discussion. So that means my lecture is already there. You have gone through the lecture. The PowerPoints are already there. You've already gone through the lecture. So now it is all about you have questions you ask. So utilize the time for a more healthier discussion. I think it's effective if you want to learn. Okay? But some students say, okay, I already got my, lecture notes. The video recording is there. I don't have to go to the class. So 180 people, you will find over 30, 40 people hanging around. Okay, so now coming back to here. So point, now you understand, right? It's just one pixel. So that is what represents actually the pixel size as well. That comes back to the resolution of the spatial resolution, that's what I was mentioning. Whether it is 0.5 meter, 1 meter, 5 meter, 30 meter, whatever. Then a line, when it is represented in this way, it becomes like this, right? Each point, this is one point, then goes like this, like that. Area ultimately, if you are to represent this polygon, it becomes like this. Okay, excuse me. Now, let's look at it actually in terms of some real life, not real life, I mean real world scenario. Okay? So in the vector you have house, there is a river, there are trees. I have drawn it so don't condemn it. Then there are some trees. Okay? Look, when you convert it in the raster, this is what it looks like, house. Obviously, I have just put that H so that you can understand. But that is, H is basically is 1 pixel length. Right? Then you have river, then there is tree, then there is H. So finally, when you want to represent this actually, this is how it looks like. Okay? And raster, that one. Alright? Yeah.
And what is the process of converting this? How this gets converted from one to another?
Oh, no, but it's just, for example, you have, it would ask you what is your cell size. First thing it would ask you the cell size. That means cell size means grid size. Grid size means pixel height. Okay. Once that is being fixed, so the number of rows and number of columns it will be automatically calculated. Then after that, it will just follow. Let's say you are converting from vector to raster. So depending on actually the vector, wherever it passes through, in XY coordinate, it will be converted into rows and columns to the respective rows number and column number.
So it will pass through the middle.
Middle. Middle. Good question. Yes, it's middle.
So because in previous slides, you have shown two sets simultaneously, like raster and vector altogether.
No, but when it's raster to vector, it goes actually where? That's a problem. It's not actually the middle. Sometimes it takes the. So different GIS software, they use just different algorithm. Okay? So that is why when your data quality is of very good quality, it becomes actually also very difficult in terms of capturing the correct information. Not necessarily that if you want very high resolution data, you can do your job correctly. Because the more error is being introduced once you process them. Understand? I have written a book 10 years ago. That book was on LiDAR data and landslide assessment in Springvale. It was published in Springvale. So that book essentially talks about everything about LiDAR and different types of LiDAR data that can be applied for landslide detection, right, to susceptibility modeling, to vulnerability modeling, risk modeling, and so on. Also debris flow modeling and everything, rockfall trajectory modeling, etc. One of the chapter, because I was curious to know that what is the optimized pixel value that I can use for landslide modeling. Okay, because obviously you think that the better resolution means it is of better quality. No. So the original data is of 0.5 meter pixel size, the LiDAR data. It's of extremely good quality data, but that gets the worst result. So the optimized data that I found, my conclusion was about 5 meter, good enough. Especially for digital elevation model. Okay? So you've got to understand, it's not that easy. Okay, this slide I've already mentioned, we can skip. This also I can explain. Okay, now, when you look at the vector data formats, it's basically a starting point, right? Where you start your first point. Then you have X, Y, and that is what you call the node, right? And then from node to node. That means first you put the cursor, that is from node to node, right? X, Y, yahan pe hua, udhar bhi hua. Then you go to the next point and so on. Then this becomes actually from node, then goes to the to node and so on. When you are driving, when you are creating a line or polygon, right? Similarly, when you are creating polygon, then it becomes the right polygon, left polygon. That's how you store the information about the relationship between the data. Okay? I'll show you some examples also. See, right polygon, left polygon, from node to node, and etc. Okay? So this is how, if you look at the vector view of the world. So it has the arcs. These are the different arcs. That means joining between 2 points. It's called arcs also. Okay? And you have also the regions. That means right region, left region, or right polygon, left polygon, etc. And this is how the vector data format actually is being captured. But these are, not everyone captures like this way. The correct way of capturing the GIS vector data is like this. That means starting point and then it goes. But when you scan the data, you don't have those information. Right? When you create the data, yes. Scanning, no, it's just actually, you just get the vectors or rasters as it is, just like that. But you need this kind of data for traffic management and especially for traffic management. Like you have one lane, you have one way. Okay? So otherwise, if you don't have that information, you can't be able to do the analysis. Your software will tell that, okay, you push people this way, but it's already one lane. Understand? So data quality plays the most crucial part in GIS. The data is of no good quality, garbage in, garbage out. Okay, you will get result for sure. It's like computer developing computer code. Okay, something for sure. Okay, so you can see the node and the arrow. This I have already mentioned, row and column, raster data format. Some examples of data format, okay, of raster data format. Digital elevation model, satellite image, digital orthophotos. Orthophotos, that's what we call it as when you use using the UAV. Okay. Scan maps, graphic files, scan graphics, and so on. This is the raster view of the Earth. That's what you saw, the vector view, and this is now the grid test. Okay, and you can see there are different types of land use classes here. Okay. You want to have some water? What you can have. Now, this I also have already mentioned about it, right? I can skip this. Now, if I would ask a question, if I am converting a vector to raster, a land use map, my input is vector, converted to raster. I have 5 types of land use map. So let's say water quality. What do you think about the pixel value? Is it going to be same throughout the? Yes? Have to be, otherwise how would you categorize? Have to be, isn't it? If you have that information, but my question was converting from vector to raster. I'm not taking actually data coming from satellite image. Okay, satellite image obviously you would have, because you have the blue band, and then obviously you have based on the sedimentation of the and the kind of reflectance values you are getting from shallow or deep, or maybe the sedimentation, chlorophyll content, everything, right? But again, there would be a range. So that range would be significantly different from the range, let's say, of land, or maybe different type of land use classes we are talking about. Okay. So raster data basically is a matrix consists of regular grid size. Regular. Okay. That means it's not like this one is 1 meter, this is 5 meter. Okay. The raster cell size has to be the same. Okay. Another understanding is that when you do the raster based analysis in your GIS, make sure all your data has the same grid size. It's mandatory. Boundary, yes. Boundary, yes, but also the number of cells. Otherwise, it doesn't make sense, because you are doing raster based assessment. Let's say, for example, ith row, ith column. If there are two different values, two different locations, what kind of assessment you can do? Right? So make sure when you create the project in the GIS, make sure that boundary conditions are being set. You can set. That means whatever data you are uploading, you can always converting it to that particular cell size. Okay, are you getting me? Everyone? Okay. Now see, the point is just one pixel value. Line goes like this, another pixel value, and the polygon goes like that. This is the area. Okay? What are the common raster data file formats also? Data format. Anything about related to image files. BMP, JPEG, GIF, then IMG, TIFF, but mostly being used as TIFF, IMG, then PNG, BMP also. Okay, depends. So all kind of data, but TIFF is the most popular. Okay, and depending on what software that you use. Are you still using Erdas?
Yes.
Yeah. Okay. Now, see, these are different data layers or map forms. Let's say forest type, this is in vector, 1, 2, 3, soil type, 1, 2, 3. See, the same area. The different forest types are, you see the boundary, the boundary of the forest is different, right? Then the soil type underneath is different. Then the topography, the contour values are different, right? The height information values. Then this is the real world. This is how it looks like. When it is being represented in the raster, you see 1, 1, 1, 1. This is 1, 3, 3, 3. Okay, the pixel values. Similarly, soil type. Finally, once you trip, actually you can do the raster based analysis, and that is what you do the overlay analysis. Okay, you can also do a lot of assessment. You can also create new data, you can do clipping, you can do overlay, you can what? Union, you can do subtraction. Okay? Provided they are all in the same coordinate system. Okay? Otherwise your India would be close to Antarctica. Right?
Sir, what is the difference between March and EMEA? March.
Same. But March, no, it's different. I'll show you. It's different. I'll show you. Okay. Now let's look at very simple geospatial analysis. Okay. Anyway, you will be doing some practical tutorials. I think day after tomorrow? Okay. I will not. It's very boring. Someone has to do it. Okay. So, what is geospatial analysis? The analytical capabilities of a GIS use spatial and non-spatial data, which is the attribute, to answer the questions and solve problems that are of spatial relevance. Okay. And this can be done through computing. So, new information can be generated from the existing piece of information. Okay. Now, let's look at what are the classification of analytical GIS capabilities. One thing you can do, classification of the data. Right? Then you can do retrieval and measurements data. All these things also you can do. Overlay functions, just now I was mentioning, also you can do. Combination of 2 or more spatial data layers. Neighborhood functions also, right? That also you can do. Like one example I have given, evaluate the characteristics of an area surrounding the feature location. One previous example, simple example I gave you, right? Let's say, okay, we'll talk about later. Then connectivity functions also between the two different features and so on. Overlay function means what you can do? Vector overlay, polygon intersection. You can do polygon clipping, you can do spatial join, you can do overwriting, you can do raster overlay. All these things can be done. But everything has to be in the same georeference system. That means the coordinate system has to be same. Okay. Vector overlay, what you can do? Polygon to polygon overlay, line on polygon overlay, point on polygon overlay. Also you can be able to do that. So that flexibility is there depending on what you want. So what happens is that during the process of overlay, the attribute data associated with each feature type is merged. Okay. So when you are overlaying, when you are doing overlaying, obviously the feature data. For example, just now I showed you, right? 3 types of land use, then you have 3 types of soil, and you have 3 types of something else was there. The contour values, right? Topography information. So when you merge them, obviously all this information, the values are all going to be merged. Okay? The resulting table will contain both attribute data. That means attribute from this, they all will be merged. Okay? One good example I have put it here. Okay? This is the rainfall data of 98. Okay? This is in grid value, it shows. This is the rainfall data of 99, the grid value. Now, if you would like to see what are the changes that has happened from 98 to 99, you just subtract. Right? Subtract. So, that is the beauty of when you do the assessment in raster. Because it's very easy. Why? Because the distal number values. And they are raster. I mean the grid values. Right? It becomes very easy. So raster-based assessment are more powerful than the vector-based assessment. So vector is basically to prepare the data. Assessment, analysis, mathematical formulations, predictions, everything you can do it in raster. Okay? So in this case, what would be the change? You can see here clearly. Alright? Okay. So यहाँ पे देखो, ठीक है? तो 5 minus 2 is 3. 7 minus 5 equal to 2. So basically, each raster is being now subtracted with the corresponding pixel value. Okay, that's what. And if you, that's what I say. If you do not have the same number of grids or rows and columns, you can't be able to have this desired result. Okay. Now you can do also a lot of Boolean operations. For example, and, not, or maybe some Boolean logic as well, false, true on the input values. Okay, like if you have A like this, B like this, A and B would be what? A or B would be what? These are very simple Boolean mathematics. We don't have to go through. So those also information can be created as well. In terms of application, I think we have already gone through a lot. I don't have to mention. Now let's look at what are the way GIS being used. Okay, emergency service, fire and rescue, environmental, storing your what you call chemical substances. Okay, you can also do a lot of analysis using the Aloha model to see what are the most dangerous substances. If there would be a likelihood of catching fire in your stores, what will be the footprint of the plume that is going to have. So a lot of analysis can be done. You can bring in the wind direction, you can bring in the wind speed and everything. You can do the scenario analysis. Okay? Business, okay, industry applications, transportation, communication, mining, that basically government is already using in every sector. GIS, okay? And education also, right? I think in the new education policy, this ICT has already become, I don't know here, but like in Australia, in year 8, they do the coding. Okay? So, and then they also have one subject called robotics. Year 8. But many students I have seen, the white student, those who don't like study, they go into other kind of courses like plumbing, or they go for like electric things and all that, but they become champion in that. They are more than a professor. And no one cares. You know? So, education is basically skill, not a degree. Our problem here is all about degree. A certificate. Certificate is a piece of paper. Now you apply for a job from here with your IIT degree also to an Australian firm. They will say what experience that you have. And more than that, what Australian experience that you have. That is why you see our degrees are sometimes dubious. Right? Because people do not have that much of trust in our system. Unfortunately, sadly. It's because everyone is just going for degree. They don't actually, try to skill development. Ultimately, it's all about skill. Problem solving. Okay? So you just have to put in one thing. That's it. Right? Isn't it? So imagine Sachin Tendulkar would have wanted to become a fast bowler. He wanted to become a fast bowler. Yeah, you know, right? Sachin Tendulkar wanted to be a fast bowler. Imagine if he would have wanted to become a fast bowler. He couldn't have become a Sachin Tendulkar. What Sachin Tendulkar we had, right? And why a person becomes extremely good in one field? Because of the practice, nothing else. So intelligence comes a little bit. More or less, all of you have similar kind of intelligence. So we have this notion he is more intelligent than me. I don't believe it. It is all about what practice that you do. How much brain that you put in to understand things. Right? Intelligence को भी माँ को पेट से थोड़ा ना सीख के आता है. Never. Genetically it is there, but then you can just fingertip, you can tell people, right? But again, people also have felt, okay, if you talk about intelligence, very good example is Vinod Kambli. He was more talented than Sachin Tendulkar. Right or wrong?
Yes.
What happened? When he came, he had 2 double centuries back to back. Sachin took about more than 150 matches, 100, 200, 120 matches probably. So, perseverance, practice, focus, okay? Not flamboyant, right? That's all about it. So similarly, in research, in education, that is all what matters. Research, especially those who come to research, that's the only thing that you have. And I don't like this notion of having plan B. I never like plan B. Only plan A. Because when you have plan B, back of your mind, you know that your mind will never put it 100%. You think that you still want to be in the safe zone. That's how minds is designed, you know. Okay? When a child actually learns swimming, okay, he thinks that, okay, oh, I'm going to drown. There's nothing else I could do. I have to swim, I have to learn. That's how it works. But when you have plan B, plan C, plan D, plan A, right? Always you have, okay, this thing doesn't work, I have another thing to do anyway. Right? So the success to be excellent is only having one plan. Nothing else. Focus on that. Okay? Now, GIS, you know that being used in every places, and all these things I will give you, you can read. There's nothing else. I have already spoken thing about it. See, just giving you some examples here. Network solution, then underground utility mapping. Okay? Like GIS is already being embedded with the what do you call this? SCADA system. SCADA system. Right? Make it very powerful. You know, power tripping, then alternate routing, all those things. One power trip, then where is the other source of immediately actually, you know, SCADA system. Okay. Then network assessment, network analysis, ecosystem management, then 3D mine, you see, 3-dimensional mining. That also can be done in GIS platform. Then environmental monitoring, toxic plume. Want to go? Yeah, sure. Then displaying methods, you see, you can have histogram, you can have tabular data, you can have graphics, you can have nowadays different software. Which one? Yeah, various display and ArcView. It's ArcView. Used to be my favorite because I learned everything.
Sir, now ArcView is in Tamil.
It's still there, but I don't use it now. But I was champion in ArcView because when I learned, 25 years ago, that time, even more. So at that time, what ArcGIS today you have, it used to be called as ArcView, obviously, and then they never had this graphical interface. So we used to do this coding, the DOS command, spatial join, this and that. So all those things I learned those days. What happened? Up to 4 days, just useless, right? So that's why do not focus too much on software-based learning. Understand the concept, okay? Oil spill contamination. So I can show you some examples that the system that we have designed and developed from scratch, having own platform. Okay? So regardless, whatever platform, doesn't matter. Then site location, client distance assessment, future trend, patient demographic, a lot of things can be done. Cluster, comparison of data, hospital management, hospital facility management, and so on. Okay, so if you like to summarize on GIS, so GIS allows you for better management, faster decision making process, and viewing the world in a different way. Okay? And being able to answer a lot of questions otherwise, which is very difficult to answer. Okay? And it also allows you to do interpretation, visualizations, and so on. Okay? Any questions you have? Everyone is looking at what's the score? What's the score? I know you are watching.
160.
For Australia.
164.
What's the, how many overs?
30.
Not bad.
So they're interested to know who do you support, India or Australia?
India, 100% India. So when we go and watch match in Sydney cricket ground, about 90% there will be blue shirts. The Indians are out there, outnumbering everywhere. So there would be just patches. But anyway, there is no problem there because they appreciate the cricket anyhow. Unless you try to escalate, right? If you just appreciate the game of cricket, it's all good. Okay, so what else? What questions you have? Any questions you have? I'm still running behind one lecture, but it's okay. Because we are doing good progress. Compared to where we were yesterday and today, so it's a good progress. Any questions you have? I think I wouldn't start a new lecture today because that's a heavy lecture. Any questions you have?
Sir, in India we have list score data of 5.8 meter resolution. So is there any satellite data like that final resolution?
But that you have to pay.
No, I'm asking for free.
Free.
Sentinel 10 meter apart from that.
There are tandem X 1 meter, but it's not free. It's not free. No. See, that's the good thing. In Australia, we have also LiDAR data for the entire country. So any data that is being captured by any government agency is supposed to be for free. Okay, so it's in the net that they have to put the data for free. That's the difference. Because here, basically, there are control, and but obviously rightly, because India has issues, right? We have got bad neighbors. Right? So bad, I mean difficult. Okay. Now it's a new difficult neighborhood come now, Bangladesh. So data security is an issue, right? But in Australia, most of the data you can download, like what we have in USGS. We also have the corresponding agencies, and Australia doesn't have a space agency didn't have a space agency until about 5 years ago. Because everything they rely on the US. But now just about 5-6 years ago, they established the Australian Space Agency. So, but obviously they have access to the data, US data. US living brother. So, and free. No, I don't think you have. Already you have 5 meters good. Free data. That's the problem because the data are expensive. And many of these satellites, they are also private owned. Like QuickBird, which is privately owned. Iconos, QuickBird is 0.6 meter. It's fantastic. Okay? But again, it is privately owned. And obviously, since they have invested money, they have to get money. It's a service, right? Then you have Iconos, that is also 1 meter, but it is again private. Then QuickBird 3 is very good. I think it's about 30 centimeter. And then one band is 15 centimeter. Okay? So, yeah. Any other question you have?
Sir, this subtraction operation will be helpful in flood map.
What?
Flood map.
What operation?
Subtraction operation.
In what sense?
Like if we have 2 images, 3 flood and post-flood or during the flood.
Oh, change analysis. Yeah, yeah. Yeah, that's what actually you like to track. I will give one lecture on flood. When you attend that, after that you can be able to do flood mapping. Flood susceptibility, vulnerability, and risk mapping. At least with whatever data is available, you can start with. The most important thing is the process flow. What to do. Even simple model like AHP also you can use to start with. The multi-criteria decision making based model. They are not 100% error free, but you can still use.
Expert judgment was difficult.
Expert can also have pagal log bhi expert ho sakta hai. And if your mood is not good, obviously the expertise would be different, right? So that is why we use the data-driven based approaches, so that we can minimize that. Or maybe you can combine both. That is why you have fuzzy logic, right? Unfis. Unfis. Okay, so fuzzy logic obviously is 0 and 1. So there is a probability based model, but at the same time you can also have, and you can develop the rules in fuzzy, right? Rules means if and then. Okay, or you can use also decision tree or random forest. Okay, because then you have a parent, child, you can create actually the rules. Okay, and then you can combine with the machine learning based approach, like deep learning, or you can also use like a support vector machine, those kind of, yeah. From my understanding and experience, support vector machine is one of the very consistent, not best, consistent. That means regardless of different kind of application, different kind of data set, always gives you a very robust output.
What about NVT? NVT? Native bus too?
Also, it's not that robust. And logistic regression, multivariate logistic regression model. Do you have here SPSS? SPSS? If you can install, then I can teach you how to do logistic regression modeling. It's a very good model, you know?
SPS.
SPSS, statistical model.
So we have the crack version.
Yeah, you can use crack version, but not officially.
Everything is there.
So if you have that, then I can teach you how to do it. Do you know, today what actually you see a lot of models that is easily available in Python and all that. When we started, it was nothing there.
Even sir, Archers has their own fuzzy logic. You can
Yeah.
just command it. And
Imagine when my first paper was on ANN, maybe 18 years ago. That was impossible at that time GIS to have ANN model to implement. Fuzzy logic model also around that time. So I had to discover everything from scratch. What kind of software I use, external software, then try to bring the data in and out. Then GIS data cannot be read there. Then what is the requirement of those data? There was no guideline because there was no merging, there is no marriage between these softwares. So that is why, because there is a branch that I developed, in spatial data analytics. So these are the branch like data mining and machine learning. So that is why I have huge followers following my research.
like God.
Yeah. I mean, on an average, I receive maybe 1,000 citations per month. Okay? So it's because of that. That's what I'm telling you. If you do something, it's never going to be easy. But lage raho. Once you crack it, that's it. It's all yours. तो plan B करोगे तो नहीं होगा ना. To do it. Some of those early papers remained as highly cited papers in very good journals. Computation geoscience, environmental modeling and software, expert system with applications, landslides. Landslide was new at that time, the journal. Today is one of the very good journal, Q1, top quality journal. They requested me actually to publish a paper. My first paper was an invited paper. I still remain as one of the highly cited paper, I think. In more than 1,000 citations. So, and still, see, when I'm telling you what are the challenges means actually there is an opportunity. When there is a challenge, when there is a problem, that is where the opportunity comes. When everything is done, there is nothing to be done. I think you can off it. Yeah.